All right, let's do another example from the Joule Thomson coefficient. So in this example, we have steam throttling from 4 megapascal and 400 degrees C to 200 kPa. Okay, so the question is asking whether the temperature of steam increases or decreases through this process. So I have two states. My state one, the steam is at pressure of 4 megapascal and temperature of 400 degrees C. This is what I have for state 1. For state 2, I have steam at pressure of 200 kPa. But this is all I have apparently for state 2. The problem statement does not give me any other information for state 2, but again, apparently, because there are some way to find more information for state 2. Now, the question is asking whether the temperature of steam increases or decreases through this process. Okay, so this process means through the throttling process. Okay, so what I know is the enthalpy H is constant through the throttling process. So this is an H constant process. So that means whatever enthalpy I have for state 1, value wise I have the same enthalpy for state 2. Okay, so all I need to do, I go to the table, I find the phase, it's superheated vapor phase, and I read H value equal to 3214.5 kilojoule per kilogram. So that is my enthalpy at state 1. But because that's a throttling process, I have exactly the same enthalpy in state 2. So for state 2, I already have the enthalpy. Okay, now the question is asking about the temperature of steam. Now think about this as a thermo 1 problem. I have a state, the pressure is given, the temperature is given. All I need to do is to find the phase and based on that the temperature. So the temperature here is going to be 369.5 degrees C. So this is the temperature of steam at state 2. So temperature initially was 400 degrees C and then the temperature is 369. So definitely the temperature is dropping through this process. So the temperature drops through throttling. That was the first part of the question. In the second part, the question is asking for the sign of the Joule Thomson coefficient, whether that Joule Thomson coefficient is a positive value or a negative value. In order to do that, I know that the Joule Thomson coefficient is partial T, partial P when enthalpy is constant. So think about this. During the throttling process, the pressure drops. You can see that the pressure was initially 4000 kPa, but at the end of the process is 200 kPa. So 4000 to 200. So definitely the pressure drops. Also, the temperature drops from 400 to 369. So the pressure drops and the temperature drops. So at the end of the day, we will have a positive Joule Thomson coefficient. So the answer is positive. All right.